evening all. Let's wait for a few minutes to everyone join, okay? Let's wait for the remaining members. Am I audible? Vishwanath, am I audible? Good evening. Shravani, good evening. Shiva Darshini, good evening. Kavya, good evening. Madhumita, Ashika. Yeah, good evening all. Welcome to my session. Yeah. Thank you for your response. Good evening. Revati Arumugam, good evening. Vigneshwar Venugopal, good evening. Surya, good evening. Prasanna, good evening. Madhumita, good evening. Nityashri, good evening. Yeah. Good evening all. I warmly welcome you all to my session. Shall we start? If you are okay, listen. Shall we start? Just drop thumbs up emoji in the chat box, please. Let's start the class. Yeah. Thank you for your response. Ashika, Shravani, Chan, good evening. Okay. Okay, let's start. So, this is our overview of program. So for the first week, what we are going to learn is introduction part. So yesterday we learned introduction of IOT, right? So today we are going to learn about introduction of esp8266 controller. So in later sessions, we'll move to ADC, pulse modulation, deep sleep, and the basic interface like combining sensors and interface sensors with different sensors, like a mini project. Okay, so for the second week we will move to web servers and cloud, like interfacing sensors with ESP8266, and we are going to uploading the data to the cloud and going to monitor it over internet. Okay, so for the third week we will go for communication protocols, like communication between ESP8266 and Arduino, and then Bluetooth interface. So coming to fourth week, we are going to see protocols, MQTT, Firebase, DIY, cloud. So protocols means like web server, Wi-Fi, email, and MQTT MQTT BME280 sensor, MQTT DHT11 sensor, and then coming to Firebase, like same Firebase BME280, Firebase web server reading, and DIY cloud. Under DIY cloud, we are going to see ESP8266 weather station. We are going to control GPIOs. We are going to view sensor readings and everything under. Okay. So this is our 20 days agenda. Shall we move to the topic? Are you people able to understand this about the agenda? Are you okay with this? Please drop your answers in the chat box, please. Yeah, okay. Thank you for your response, Ravani, Manikandan. Okay. So first, introduction to ESP8266 node MCU. So what is ESP8266 node MCU? Have you ever heard about this ESP8266 node MCU? Have you heard about it, or have you used this microcontroller before, or do you have any idea about this? IOT module, okay. No, okay. Have you done any mini projects using this microcontroller? Sort of advanced version of Arduino, okay. Okay. So now let's see what is an ESP8266 node MCU. So the ESP8266 is a low-cost Wi-Fi chip that is developed by esp8266 systems. So it can be used as a standalone device or as a UART Wi-Fi adapter to allow other microcontrollers to connect to a Wi-Fi network. So for example, you can connect an ESP8266 to an Arduino to add Wi-Fi capabilities to your Arduino board. So the most practical application is using it as a standalone device. With ESP8266, you can control inputs and outputs as you do with an Arduino, but here with Wi-Fi capabilities. This means you can bring your projects online, which is great for home automation and Internet of Things applications, right? So now, this is our ESP8266 node MCU. It is a low-cost Wi-Fi chip developed by esp8266 system. It can be used as a standalone device or as a UART to Wi-Fi adapter to allow other microcontrollers to connect to a Wi-Fi network. So why is this microcontroller so popular? Because of these features. First one is it is low cost. You can get ESP8266 boards starting at around 250 rupees to 500 rupees, but depending on the model. Then coming to low power. So the ESP8266 consumes very little power when compared with other microcontrollers and can even go into deep sleep mode to consume less power. And then Wi-Fi. So the ESP8266 can generate its own Wi-Fi network or connect to other Wi-Fi networks to get access to the internet. This means the ESP8266 can access online services to make HTTP requests or save data to the cloud. For example, it can also act as a web server so that you can access it using a web browser and be able to control and monitor your boards remotely. And it is compatible with the Arduino programming language. those that are already familiar with programming the Arduino board were happy to know that they can program the ESP8266 in the Arduino style. Have you ever used Arduino board before? Or done any mini projects using Arduino microcontroller? Please drop the answers in the chat box, please. Have you ever used Arduino microcontroller board before, or ESP8266 or other variant in Node MCU microcontrollers? Yes, okay. Okay. Yeah, it's good to hear that. You have done so many interfaces before, right? No, Radhika, no ma'am. Okay. So, then it is also compatible with MicroPython. So, you can program the ESP8266 with MicroPython FilmFab, which is re-implementation of Python 3 targeted for microcontrollers and embedded systems. So, we can program this using C language and also MicroPython, which is embedded C. I am talking about embedded C. So what can you do with an ESP8266? Here is a short list of what you can do with ESP8266. Okay, you can create a web server to control outputs. You can create a web server to display sensor readings. You can send HTTP request. You can control outputs. You can read inputs and set interrupts. You can data logging projects. You can do communicate with third-party services. You can create web applications. You can send emails, notification, post, tweets, etc. So later we will be learn all of these in later sessions. Okay, we will get a clear idea about it. Now I am going to just introduce all the things. In later session we will do interface and everything remaining on top. Now ESP8266 12E Wi-Fi chip. So this is the one we are going to use in this entire session. Our microcontroller name is ESP8266 12E Wi-Fi chip. So first the processor name is Extensa single core 32-bit L106. So it is a 32-bit RISC microprocessor core based on the 10 silica diamond standard 106 micro, which is running at 80 or 16 megahertz, which is nothing but clock frequency. Then coming to memory, it contains 32 KB instruction RAM, 32 KB instruction cache RAM, 80 KB user data RAM and 16 KB ETS system data RAM. ETS is nothing but long term storage. It is capable of storing large amount of data and offers constant time data access. Okay. And coming to Wi-Fi range, IEEE 802.11 PGN Wi-Fi. So it consists of 17 GPIO pins. And it also contains SPF, this serial peripheral interface bus. It also contains I2C for software implementation and I2S. I2S is nothing but integrated inter-IC sound bus. Interfaces with DMA, sharing pins with GPIO. So I2C used to connect for general inter-IC communication, which is like that is EEPROM or sensors. But coming to I2S is used only for audio devices. And then UART on dedicated pins plus a transmit only UART can be enabled on GPIO2. And also it consists of 10-bit ADC, successive approximation ADC. And coming to I mentioned the difference between A266 and ESP32, but I don't know why it doesn't show here. I'll show you in this difference between ESP8266 and ESP32 in tomorrow's class, but now I will tell just the differences between the both controller, okay? So sorry for this. So there is a successor of the ESP8266, which is ESP32. ESP32 is the successor of ESP8266. The ESP32 combines Wi-Fi and Bluetooth and is dual core, okay? So if you are taking the ESP8266 microcontroller, in the sense I already told, it is extensor single core 32-bit, right? So coming to ESP32, it is dual core 32-bit, LX6 with 600 DM IPS. So ESP8266 doesn't have inbuilt Bluetooth, but ESP32 has inbuilt Bluetooth and BLE, which is Bluetooth low energy. And ESP8266 only have 80 MHz clock frequency, but ESP32 has 160 MHz clock frequency. So ESP8266 doesn't contain static RAM and flash, but ESP32 has these features, static RAM and flash. And ESP8266 consists of only 17 GPIOs, but ESP32 consists of 34 GPIOs there. And coming to pulse width modulation channels, ESP8266 have 8 channels and ESP32 has 16 channels. And ESP8266 has 2 SPI, 1 I2C, 2 I2S and 2 UART. But ESP32 only has 4 SPI, 2 I2C, 2 I2S and 2 UART. And coming to ADC, you can have 10-bit ADC in ESP8266, but there is 12-bit ADC in ESP32. And ESP8266 doesn't have inbuilt touch sensor or temperature sensor or Hall effect sensor, but ESP32 has all of this. Inbuilt touch sensor, there is temperature sensor and Hall effect sensor. So this is about the little difference between ESP8266 and ESP32. But these are the versions of ESP8266. So there are several versions of ESP8266. The ESP01 and ESP12E are most popular versions, this and this. You will find a wide variety of development boards with ESP12E or ESP12F chips, okay. And coming to this ESP8266 Node on Sieve development board, this is our ESP8266 Node on Sieve board. This is the chip and this is the development board. So using bad chips, this is if you are taking this one, this is the bad chip. This is the development board. So using bad chip or module is not easy or practical for learning or for testing or for prototyping. You will want to use ESP8266 Node on Sieve development board, right? These comes with all the needed circuitry to apply power, to upload code, easy access to the GPIOs. But see this, it's difficult. You can connect sensors and actuators, an antenna for the Wi-Fi signal and other useful features. So this is about the development board. So how to choose an ESP8266 development board? How to choose? There is a wide variety of ESP8266 boards from different vendors, right? So while they all working in a similar way, some boards may be more suitable for some projects than others. When looking for an ESP8266 development board, there are several aspects you need to take into account. So what are they? First one is USP2 UART interface and voltage regulator circuit. So most full feature development boards have these two features. This is important to easily connect the ESP8266 to your computer to upload code and apply power. Then coming to boot and reset enable buttons. This is to put the board in flashing mode or reset the board. And coming to pin configuration and the number of pins. To properly use the ESP8266 in your projects, you need to have access to the board pinout, like a map that shows which pin corresponds to which GPIO and its features, right? So make sure you have access to the pinout of the board you are getting. Additionally, some boards have more accessible GPIOs than others. That's a factor you should take into account depending on your project feature. Then coming to size, there is a wide variety of ESP8266 development boards with different sizes. Some boards benefit from a small form factor which might be very practical depending on your project features. Usually smaller boards have a smaller number of available GPIOs like ESP01. Then coming to antenna connector, most boards come with onboard antenna for the Wi-Fi signal. Some boards come with an antenna connector to optionally connect an external antenna. So adding an external antenna increase your Wi-Fi range. So these are all you have to see before choosing a board, okay? Now ESP826612E Node MCU kit. So the ESP12E Node MCU kit is one of the most used ESP8266 development board. It features 4 MB flash memory, access to 11 GPIO pins, and one analog to digital converter with 10-bit resolution. In addition, the board has a built-in voltage regulator. And you can power up the module using the mini USB socket or the DIN pin. So uploading the code to the board is as easy as uploading code to the Arduino. And also there is no need for a programmer or extra circuitry as it has a built-in USB to serial converter. So there is no need for a programmer. You can easily upload your code to your microcontroller just by using the USB cable. So most boards comes with the CP2101, which is USB to UART or CH340 chips. And also it comes with an onboard antenna for Wi-Fi signal and comes with reset and flash buttons to reset the board and put it into flashing mode. So there is a blue LED internally connected to GPIO2, which is very practical for debugging. So this is the ESP8266 board model we use more often in our Wi-Fi and IoT projects. It's very versatile and it's great for beginners. So if this is your first time with ESP8266 in the sense, this is the module I recommend, which is ESP826612E Node MCU kit. So then other popular ESP8266 development boards. Other very popular ESP8266 boards are ESP01 and the ESP8266 Venus D1 Mini. while I don't recommend the ESP01 for beginners. And the ESP8266 VMOS D1 Mini can be a good choice. So first ESP01. So this is super small and fits in any enclosure. So it's perfect for finished projects. However, it is very limited in the number of accessible GPIOs and doesn't have a built-in voltage regulator. So you need to use a 3-volt power source for this. Or you need to add a voltage regulator to drop the input voltage to 3 volt. Additionally, it doesn't come with USB to serial converter, which means you need a programmer for this or a specific programmer board to upload code. But in VMOS D1 Mini, it offers 4 MB flash memory, 11 GPIOs and 1 ADC pin in a minimal and small setup. The community has developed a wide variety of shields for the D1 Mini board, so which allows you to build small and simple setups with almost no wiring required. You just need to stack the shields to connect multiple peripherals. It comes with the built-in voltage regulator also and USB to UART converter, which makes it easy to upload the code, right? So for these reasons, this might also be a good choice for beginners. There are many other versions of different ESP8266 boards, but most boards work in a similar way. Just make sure they are suitable for your project requirement. I don't know why it doesn't show the table code properly. So here I mentioned the difference between ESP01 board, ESP12E mode, Node MCU and VMOS D1 Mini. But this also I will show you tomorrow, guys. I'm sorry for this. Let's move to the next slide, okay? So this is ESP826612E chip pinout. I am talking about chip pinout, not development kit. Okay. Are you guys able to understand this? Are you clear with this? If you understood in the sense, just drop thumbs up emoji or yes in the chat box, please. Okay, thanks for your response. Now I am just introducing all the things. When we move to the next session, we will learn everyone in detail and deeply. Okay, so later you will understand better. Introduction session in the sense you will get you guys get little confusion, but later class you will get a clear idea about it. I will explain every single topic in next session. Okay. You don't worry about the project. I will provide assignments I will provide you 4 assignments. Like 5th day, 10th day, 15th day and 20th day. You will be provided by a link by our team. You just have to submit your assignments over the link. I will explain it about later. When I give assignments, I will explain all the remaining things and all. So don't worry about that. For doing assignments, you guys should have hardware with you. You should have components with you. Then only you can interface, right? Do you have microcontroller or any basic sensors with you? Or are you able to buy these things? And also you don't need teammates for doing this project. You can do it by yourself. Hardware means I am talking about the components like microcontroller, the sensors, the jumper wires. I am talking about the components and all. You have to write the code in the IDE and you have to upload the code in the microcontroller, right? For that you should have microcontroller with you. That's why I'm asking. Do you have any components with you? Or are you able to buy these things? If you don't have components with you in the sense, no issues. We will go for some other thing. Simulator, no. Can't able to buy. Okay, it's okay. We will go for another solution for this. I will tell you guys in the assignment session. Okay, so don't worry about that. We'll talk about it later. Shall we move to the next slide? Okay. Okay, thank you for your response. Shall we move to the next slide? Okay, let's move to the next slide. So now, esp826612E chip pinout. So a pinout is like a map that shows which pin corresponds to which GPIO and its features. This way you should know which GPIOs to use if you need to use SPI, I2C, ADC or others. If you are going to use this transmitter receiver pin in the sense, you should know right which pin is correspond to the respective pin. So if you are going to interface TX and RX in the sense, you should know which pin is correspond to TX and which pin is correspond to RX. So the ESP826612E chip comes with 17 GPIO pins. Not all GPIOs are exposed in all ESP8266 development boards. Some GPIOs are not recommended to use. Okay. So and others have very specific functions. So note that not all GPIOs are accessible in all development boards, but each specific GPIO works in the same way, regardless of the development board you are using. So at the moment, there are a wide variety of development boards with the ESP8266 chip that differ in the number of accessible GPIOs, size, form factor, etc. So coming to this ESP826612E node MCU kit pinout diagram. So this is actually how your microcontroller looks like. Here they will mention the GPIO pins. Here's your antenna, here's your chip, and here's the voltage regulator, reset button, flash button, and the inbuilt LED and the remaining things on top. Okay. So these are the peripherals. So the ESP8266 peripherals include 17 GPIOs, SPI, I2C, I2S, UART and 10-bit ADC. So let's see one by one. I think there is an issue with the tabular column. It doesn't show properly. So sorry for this. 1 minute. We'll wait for 1 minute. Okay. So how to program the ESP8266? There are many different ways to program the ESP8266 using different programming languages. C, MicroPython, Lua and others. So our preferred method is programming the ESP8266 using the Arduino programming language with Arduino IDE. So we are going to use Arduino software for ESP8266. So for beginners I recommend getting started with Arduino IDE. So to program your board, you need an IDE to write your code, right? So if you are just getting started with ESP8266, you can start with Arduino IDE. So for that, just go to Google. Here search. You guys are attending class in mobile phone or laptop? Okay. If you are using mobile in the sense, just note it down the installation process. If you are using laptop in the sense, just follow the steps one by one. Or if you find out any inconvenience to install all these things in the sense, just tell me in the tomorrow's class. I will help you with that. Okay. If you are using mobile in the sense, no issues, just note it down. So first I am going to install Arduino IDE. Just type in Google Arduino IDE. So here you will get the official site Arduino. Click this. So here it will show the OS. If you are using Windows, if you are using Linux, if you are using Mac OS in the sense, go to corresponding. So now we are going to download for Windows. Click this and you just click download. Your Arduino IDE will download here. So I already downloaded it. So for that I am going to cancel it now. If you are downloading this in the sense, you just have to extract this file. Just click extract. You will get your Arduino IDE in your desktop. Okay. Are you clear with this? Just please reply in the chat box. Are you clear with this? Okay. I will move to the next process. So after downloading IDE, we have to install ESP8266. So we have to install the ESP8266 in the Arduino IDE. Then only we can access ESP8266 board in the Arduino IDE. So to be able to program the ESP8266 node and CU using Arduino IDE, you need to add support for the ESP8266 boards. So for that, we just open Arduino software. Just wait for a few minutes to open this. Sorry guys, wait for a few minutes to open my Arduino IDE. Yeah. It will take some time. Let's wait for a few minutes. Okay. I will go for new sketch. I'm really sorry for making you people wait. So yeah, here it is. So now what we have to do is that in file preference, here we have to add this link here. So note it down. So this is the link, you have to paste it here in additional boards manager URL. If you paste the link here, in the sense you will be able to download the esp8266 package. So you can get this link from Google also. Here you can just type esp8266 package link. Okay. So this is the one. So you just copy this link and paste it here. Click OK. So now open board manager. So go to tools, here board manager. Here you have to download the esp8266 board. Just type esp8266. So here it is, esp8266 by esp8266 community. Check out the latest version this and click install. I already installed this. So it show like remove and install here. So if you guys are not installed this, in the sense, just click install. That's it. So then, for checking purpose, what we have to do is that go to tools, board. So if you successfully install your board, in the sense, it will show like this, esp8266, esp32, Arduino. So click this, you will get the corresponding board. So here we are using esp12e module, right? So here it is. And also you will be provided by examples also here. Here you will get the esp8266 examples. If you go for basics, and here is the blink. So now let's do one program for basic program like LED blinking program. So click this. So already they are providing the LED blinking example program. Here I am going to just change the pin number. So it already given LED built in, but I am going to change it as pin number D5. So same here, D5. So here also D5. So this is our LED blinking program. Now what I am going to do is that, before that you have to check whether you connected the board. So go to board, ESP8266, click Node MCU 1.0 ESP12E module, not 0.9. Because this is ESP12 module. Here we are using 12E module. So select the correct board. And also you have to click the port also. So it doesn't connect the board yet. So I am going to connect this. So if I connected my board to my PC, in the sense, here you will get your port. Tools, port 4. So this is our port and this is our board name. So click COM4. D5 is our pin number. So in ESP8266 board there are 17 GPIO pins, right? So you can use any pin. You can use D1, you can use D2. Here I am just using D5. So you have to mention D5 or 5. Are you clear? So now what we are going to do is that we are going to upload this code into our microcontroller. Are you guys understood this? So now let me open the hardware part. For that we have to make connection, right? So This is our component that we are going to use. This is our breadboard and this is our ESP8266 microcontroller. What I am going to do is that I am just going to connect the LED and resistor. Are you able to see this? Is it clear? Okay. First place your LED wherever you want in your board. And here I am taking 220 ohm resistor. So connect one end of the resistor in the positive side of the LED and place the other end somewhere. So first I am going to ground it. So the negative side of the LED should be connected with the ground pin of ESP8266 and the positive side of the LED should be connected with pin number D5, right? So here it is. So now what I am going to do is that I already upload the code. So the LED start blinking. So if you just click, wait, I will show you. If you just click this upload button, your code will upload to your microcontroller. So here it will show the status here. So here it will show like this compiling sketch is compiling now. It took some time to upload your code into your microcontroller, so let's wait for a few minutes. So yeah. Are you able to see here? It's connecting. We'll wait for upload it. It is like 100%. So yeah, it's uploaded. So here you can able to see the LEDs blinking, right? I already uploaded the code before, so that's why it's already start blinking. So after you uploading your code, in the sense your LED will start blinking like this. Are you able to see this? This is our output. Did you guys understood? Please drop your answers in the chat box, please. So today we just learned about the introduction part. So when we move to the later sessions, we will be able to learn every single topic. About the pin, about the interfaces, about the sensors and everything and all. I will explain everything in later session clearly and properly. I am sorry for that before the tabular column issues. I am sorry for that. So tomorrow I will explain it properly. Yeah, thank you for your response. So this is all about today's session. So let's catch up at next topic. in tomorrow's class. So thank you for all. Thank you for your response and thank you everyone.